we solve each cycle for the n value. So we start off cycle 1. These were the values that we determined before in the chart, and then these were the other constants. So the first thing you do is solve for r, which is sigma a divided by sigma m, which is 100 ksi over 25 ksi, which comes out to 4. Now you have everything to plug into this Gerber equation here, which is 4 squared times 186 ksi squared divided by 2 times 94.116 ksi. That's all times -1 plus the square root of 1 plus 2 times 94.116 ksi divided by 4 times 186 ksi squared. Okay. And that value comes out to 92.656 ksi. Now what you do is compare this value to sigma a. In this case, sigma a is greater than S sub AF, so you continue down with this equation and solve, so it becomes 100 ksi divided by 1 minus 25 ksi divided by 186 ksi squared. And this comes out to 101.84 ksi. The last thing to do for this cycle is to plug those values and the ones we got before in. So 101.84 ksi divided by A, which was 225 ksi, raised to 1 over -0.06336. So n sub 1 comes out to 2.88 times 10 to the 5th. Okay. Now we can move on to the second cycle. So for cycle 2, sigma a was 12.5 and sigma m was 62.5. So 12.5 divided by 62.5 gets you 0.2. Now we can plug all the variables into S sub AF, so that's 0.2 squared times 186 ksi squared divided by 2 times 94.116 ksi. So times 1, -1 plus the square root of 1 plus 2 times 94.116 ksi divided by 0.2 times 186 ksi squared. Simplifying that out, you get S sub AF is equal to 30.57 ksi. Now again, we compare this value to the value for sigma a. In this case, S sub AF is greater than sigma a. So since this is the case, we now say n sub 2 is equal to infinity, and we're done with cycle 2. Moving on to cycle 3, these were the values that were solved for sigma a and sigma m. Looking at sigma m, you can see that it's a negative value. Since sigma m is less than 0, we also say that n sub 3 is equal to infinity. Okay, we can move on to the last part of the problem now, which is using Minor's rule. Okay, so for our case, we had 3 cycles, so the Minor's rule simplifies to n sub 1 divided by n sub 1 plus that all equals 1. Now in this case, if you go back to the beginning, where we have the 3 cycles with all of the values here, none of the values, okay, are the same for each of the cycles. Okay, these two are close, but there's the negative in front of the 62.5. So in this case, you can say n sub 1 is equal to n sub 2, which is equal to n sub 3, which you just simplify to n. So this whole equation becomes n times 1 over n sub 1 plus 1 over n sub 2 plus 1 over n sub 3, and that all equals 1. Okay? So the last part is just plugging in the values we got before to solve for n. So n times 1 over 2.88 times 10 to the 5th plus 1 over infinity plus 1 over infinity is equal to 1. These two go to 0, so n is equal to 2.88 times 10 to the 5th, and this is cycles before failure. And that's the end of the problem.